In this video, I'll be going through the question you see on the screen here from the 2023 Leaving Cert Higher Level Maths Paper 2. If you're looking for a different question from this paper, check out the description below. There should be a playlist there. And if you're looking for a different paper entirely, have a look around on my channel. I'll be doing all this on a whiteboard, hopefully like you're used to your teacher doing. But we are on YouTube, so take advantage of the features there. Watch it at half speed or double speed, and certainly pause and try the question first. If you find this video or any of my videos useful, I would greatly appreciate a like or subscribe, but what helps especially is sharing it with a friend that might be doing the Leaving Cert this year or next. In question 7 part A, they just give us this diagram of a hill. It's 70 meters long and the height is 9 meters, and they tell us the gradient of the hill is the height divided by the length, rise over run. That's the slope really. The gradient and the slope are the same. But they say we can write it in percentage form. Well, they want the answer in percentage form. Really, we're getting the slope. A few ways to do this. You could actually get the angle here. The angle's related to the gradient. The tangent of the angle is the gradient. But the more common way would be, let's just find this length here. It's Pythagoras theorem. Let's call it x here. X squared plus 9 squared is equal 70 squared. Solve that out. We get x squared is equal, 70 squared minus 9 squared, square root of that, and we find x is 69.419. Okay, make sure you have enough decimal places for your final answer. I like to just save it in my calculator. It's saved automatically as the answer. I then get 9 divided by answer in my calculator. 9 divided by this, 9 divided by 69.419, and that gives me 0.1296. That's going. They want that in percentage form. Don't get scared, it's just multiplied by 10. It's just 12.96, so on to the nearest percent. So 13 is the answer they're looking for there. In part B, they give us a picture of a hill, a cyclist going up a hill, and they say they drew this diagram. Here's someone standing at the bottom, looking at the top of the hill, and I guess this point here is an invisible point in the middle of the hill somewhere, and they went 20 meters to the side, and they measured their angle back to the start. It's hard for me to get my head around this picture, to be honest. I much rather that if it was, I guess, 2 triangles, one like this and another like this, that these are the same, because I'm not sure if this is meant to be 3-dimensional or not. I guess it is, and it's fine. Anyway, it's a bit confusing to me. This is sort of what they're talking about. They're at the bottom of a hill, the angle 17, what's the height? It's just they don't know. That maybe they can't get the length here because it's a wobbly hill. But what they could do is they could walk 20 meters to the side, and again, maybe for some reason they can't measure the angle from this other point to the top of the hill, but they can measure the angle back to the start, and that was 88 and 87. I guess no, it still doesn't make sense to me, because how do they measure this angle to an invisible point in the center somewhere? But anyway, I don't need to make it make sense in my head. They've given me these pictures. All we have to do is solve the maths of it. They want to find this length. Forget the story. Just solve this length. This is a right angle triangle. All I need is anything. I have 2 bits of information already. Anything about this triangle, I can find it. So I would concentrate on this line here. What's the length of that? So I'd concentrate on this triangle. Find this length. And I know 3 things about this triangle, so I can find anything. So it's not a right angle, can't use those formulas. So first thing, I try and use the sine rule. It might not look like you can use the sine rule. We have a length angle across from it. No, but yes. I can work, that's just 5 degrees. I know these 2 angles, I know that one. So I have a length 20 divided by sine 5 must equal to this length, whatever, let's call it x. It's x here. X divided by sine 87. Rearrange this, that comes up here, sine 87. Putting it all in the calculator, we'll get x is equal, let's see, X is equal 229.1597. Put that in your calculator somewhere and solve this question. We now have X. What's Y over here? It's a tangent. Tan of 17 must equal Y over this X. Rearrange that, we get Y is equal to tan of 17 multiplied by X. We know X is in your calculator, should be sitting on the screen of your calculator as you do this question. So you just type, on your calculator, type multiply by tan 17 and you will get the final answer. To the nearest meter, you'll get 70. In part C, I think it's the same person. She's doing a test for lung capacity. That's when you breathe in, breathe out. You're often hooked up to a machine. It tells you how much air is in your lungs and the volume of your lungs. And you've probably done it in PE. They give us this formula for it. Phi is equal to 2 minus 0.4 cosine pi over 2 t. And it looks like this when we graph it out. And they just want to find what are the maximum and minimum values of this. And they're marked here as A and B. A being the minimums, B being the maximums. So how do we do this? We can do it quite easily just by knowing how to read trigonomic functions, cosines in this case. I'll draw a few pictures. Cosine. We know cosines, what they look like. They look like this. The highest they get to is 1 and the lowest they get to is -1. That's what a normal cosine looks. It doesn't matter what's in it. It changes the frequency of things, how bunched up or stretched out they get. I don't care about this. The maximum height of this is 1 and the minimum is -1. But then, what happens if I multiply it by 0.4? Well, 1 multiplied by 0.4 becomes 0.4. And -1 by 0.4 becomes -0.4. Now, this bit, the maximum it gets, 0.4 and the minimum -0.4. Multiply by minus, well, I don't really care actually because it changed the shape a little, but still the maximum would be 0.4. Lowest be that. Then I just add 2 on. So add 2 on to both of these. This one becomes 2.4 and adding 2 onto minus 0.4 becomes 1.6. And that's it, 1.6, 2.4. Just from knowing how to read this. Cosine just goes between 1 and -1. So any number in front of it really just goes up and down this number. That's what it means. Add it on to 2. That's what you get. You're going around 2. 2 is the center. And this is what you go up and down. D is just an English question. D asks us, what's the connection between V prime, the derivative of V, and Olga breathing in and out? So what does this number tell us about her breathing in and out? Well, if we look at the derivative, the slope of a function, this, at the lowest point it's 0, then it's a positive, it's a positive, it's a positive. It becomes 0 again, it becomes a negative, negative, less negative but still negative, 0, up and down. So really when this is bigger than 0, she's breathing in. So bigger than 0, breathing in. And the same when it's less than 0, breathing out. That's all they want for part D. In part E, they simply ask us to find how much volume is in our lungs after half a second. This, I'm not sure. Yeah, I don't have it. I think this went up to 9 seconds or something. So after half a second, how much is in her lungs? We simply do that with this formula. That's just V a half. And we put a half into this, put it into your calculator. You'll end up getting, let me write it out, 2 minus 0.4 cosine. The only thing the half will do is in here, pi over 4. Put all that into your calculator. And let's see, you should get, here it is, 0.44428 to the nearest 3 decimal places, so 0.444. For F, they want to know the volume, find the rate at which the volume in our lungs is increasing half a second after. So after half a second, it's increasing, they're telling us. We don't need to know that. The answer will find that for us. But what's the value of it? Well, we need to know the derivative. So we have to find the derivative first. And that's easy. The derivative of 2 is 0. Then we're just minus 0.4. The derivative of cosine, well, that's actually minus sine of whatever's inside it, pi over 2t. With just some exceptions. If what's inside it here is not simple, well, it's not an exception really. We have to differentiate what's inside it. Usually we don't bother because it's just t. The derivative of t is just 1 multiplied by 1, doesn't matter. But no, using the chain rule, we have to differentiate what's inside it when it's complex. And the derivative of this is pi over 2. Sorry, differentiate what's inside it and multiply by it. This again, this is just, we're differentiating cosine of ax. This will be in your formula tables. So that's the derivative. Then we just put in a half. Phi prime a half. Put all that in. Again, you can do it on a calculator. The only thing different here is it's sine pi over 4 multiplied by minus 0.4 multiplied by pi divided by 2. And the answer is actually what I wrote down up here, 0.444. And this one here is wrong, which I hope nobody typed in before I got the chance to fix this. It's 1.717, which of course it is, because it couldn't have been this number for this previous part. This number down here, it didn't make sense. I never checked my answer. I deserve to lose marks for that one. So apologies for that. The last part is a lot of writing, but I don't actually need to do much work. I can squeeze it all in this area. They paint us a picture with words. They describe this again in a new way. Let me just clean this off. They describe a world where the maximum is 3.6 and the minimum is 1.3. We don't even have to change the shape of this because we do have to change a bit of shape of it. The starting shape, they tell us seconds after breathing out fully. After breathing out fully, so our lungs are empty. So we're starting at this point down here. And then the thing that changes is she breathes twice as quickly. Now, some people aren't good at this. Well, the picture should be easy. It's just twice as much rather than being stretched out. And the question really is just to draw this picture. So what we did in the first part, we went from this to the picture. This time we have to go from a picture to something else. It looks something like this. The answer will have a number. It will have a plus or minus and a number here. It will have a cosine or a sine. They both work actually. I think they tell you to use cosine, so that's good. Because we can always use sine. It's just shifted by adding a number in here. Adding 90 in here, I guess we'll do it. And a number in here. So this is all we have to do. Remember this number out front, this 2. What it told us in the previous thing was the middle part. That's what this should tell us here. What's the middle of these two? It's 4.9. Half of that is 2.45. Let me just check my answer. Yeah. This number here tells you how much it goes up and down. When there's a 1 here, a normal cosine, it goes up 1, down 1. How much does this go up and down? 2.45. What's the gap between this and this here? It's let's see, it's 1.15. Again, just double check. Yeah, 1.15. It's a cosine. Cosines start, if I just draw a normal cosine over here, cosines start at the top. This one starts at the bottom, so I do need a minus here. That's I wonder would you have lost marks for leaving a plus there? Maybe, maybe not. It's such a subtle, small thing because they did say after she breathed out fully. So we did know it started at the bottom. Anyway, so what's in here? That's the last thing. She breathes twice as much. So previously there was what was it previously? It was pi over 2t. Twice as much as that is just pi t. Play around with that. Some people aren't good at that. Cosine looks like this. Cosine of x looks like this. Cosine of 2x looks like this. Make sure you know the difference. Cosine half of x gets stretched out. Make sure you're happy within the difference. I'm never good with this. I always just do a little test. I put in 45 degrees, 2 45s, what number, and I have to draw the picture every time. Anyway, that's your final answer for that part. They didn't ask what A, B and C were, but A would be this. They have a positive on theirs, so B would actually be minus this number, and C would be, pi. They didn't ask for that, they asked for this formula though. Okay, that finishes up question 7. If you have any follow-up questions, let me know in the comments. I was a bit rushed in this one, I think, but let me know if you need any extra help. I'll do my best to get back to you. Thanks for watching. Have a great day.